The adjustment of tonal values such as exposure, contrast, and white balance is one of the most common photo editing tasks. Here we show some adjustments being applied globally to an image. However, in many cases, it is desirable to have these adjustments only apply to localized image regions. A particularly challenging example of image adjustment is the process of tone mapping a high dynamic range photo in order to display it on a low dynamic range medium. Two recently published tone mapping techniques are Reinhardt et al., Fatal et al. These techniques are fully automatic, which is impressive, but can limit the creativity of a photographer. Countless different interpretations of an image are possible. For example, this, or this, or this. Our new technique created these results by providing a simple yet powerful means for a photographer to guide the digital tone mapping process. The technique is simple because it only requires specifying the desired adjustment, such as exposure or saturation, and a rough indication of the region to be adjusted by drawing a scribble inside that region. The hints are input as soft constraints to an automatic solver. The result is an adjustment map for the entire image. The solver is fast enough to give near real-time feedback to the user. This allows the user to iterate as necessary by adding additional constraints or refining the adjustments. Notice the small number of constraints necessary to tone map this image. Even though a single small stroke was indicated on the interior portion of the scene, it was sufficient for our solver to compute an appropriate adjustment map. Similar adjustments can be performed in a tool such as Photoshop. In Photoshop, one approach would be to apply masks to regions of interest and apply different adjustments to those regions. Here, we asked a Photoshop user to tone map the piano image. Pixel selection is a laborious task. Let's check back on him later. Our solver produces an adjustment map by taking the user's constraints and intelligently propagating them across the image. The desired map should meet the constraints, yet be as smooth as possible. The map should also be allowed to change rapidly at significant image edges. After making strokes and seeing an initial solution, a user may want to fine-tune the parameters associated with the strokes. When using our application in this mode, it is useful to solve for the influence functions associated with the strokes instead of solving directly for the adjustment map. A new adjustment map can be computed by simply multiplying the influence function by the updated parameter and adding to the current map. This allows us to provide instantaneous feedback of the updates. For some images, the simple stroke selection mechanism isn't the most efficient way of specifying constraints. For example, in this image, we'd like to simultaneously select all of the sky region showing through the tree branches. Here, we show the color pick brush being used. These selections are used as constraints just like the scribble-based constraints shown earlier. Inspired by Ansel Adams' zone method, we have also developed a completely automatic way of setting the constraints. This involves decomposing the image into zones, computing an appropriate exposure value for each zone, and solving for the full exposure map. Here we blink between our automatic result and Reinhardt's automatic result. Notice the additional contrast in bright regions. A variety of image adjustments could be applied by our method. We have primarily shown exposure, saturation, and contrast. However, many others are possible, such as blur and white balance. Of course, the system can be used to adjust low dynamic range images as well.
Maybe I'll just stop here.
We end with some of our favorite results.